Okay, today we're going to be learning about interval notation. Okay, the first thing we're going to do is we're going to write this as an inequality. We always use the letter X to represent all of our solutions. In the graph of the number line, the solutions are represented by the shading, right? So our solutions start where? At 3. And then they're what than 3? Less than 3. Is 3 included in that solution set? Why not? Right, it's an open circle, not a closed circle, so that means it's not included, so you just put less than 3, you don't put an equal to bar. Now we're going to learn how to write this in interval notation. We're going to do a lot of these, so just keep watching. Just keep watching. Okay, so interval notation, we read it from left to right. So, on the left side of this shaded part, where am I? What does that arrow mean? Infinity, and isn't it on the negative side, so negative infinity? And then if I go to the right side, where do the solutions end on the right? 3. Okay, now, a bracket means included or closed. A parenthesis means not included or open. So, parentheses always will go on your infinities because we will never be able to include infinity. You will never reach infinity. Okay, in this case, 3 is also going to get a parenthesis because it was not included. It was an open circle. All the solutions are less than 3. They're not 3. They're just less than 3. Okay, so now let's try the next one. We have a closed circle at 0. See how that circle was shaded in at 0? That means 0 is included in the solutions. So the solutions are what than 0? Greater than or equal to 0. Because isn't all the shading on 0 and above it? So greater than or equal to 0. Okay, now we're going to write this as interval notation. From left to right, where do your solutions start on the left side? 0. And then how far do they go on the right side? Infinity. And since it's going right forever, it's positive infinity. Now remember, infinity is always going to be parentheses because you can't include infinity in your solutions. You never actually reach infinity. But in this case, 0 is included, so you show that with a bracket. Does that make sense? Okay, now let's look at number 3. They did the opposite. They gave us the inequality. They want us to do a number line. So go ahead and draw yourself a number line. And don't write every number. Just write these numbers. -6, 0, and 6. Okay, which number do I circle? Is it opened or closed? Open. How do you know that? Well, there's no equal to bar. So that means all the solutions are just greater than 6. They're not equal to 6, so we show that on the number line by not shading it in, not closing it. To show the solutions are greater than -6, which way do I shade the number line? To the right side. Okay, so everything will be shaded this way. Now we need to write that as interval notation, and when you're writing in an interval notation, you read from left to right. So, the shading starts where? -6, and it goes where? Infinity. -6, bracket or parenthesis? Right, because it's not included in the solutions. It's open circle and there's no equal to bar. Infinity is always parentheses. Okay, why don't you take a second and try 4, 5, and 6. Number 4 reads X is less than -5. So when I set up my number line, I'm just going to put -5, 0, and +5. Which number do I circle? The -5. What kind of circle do I do? Open, because there's no equal to bar. It's not included in the solutions. All the solutions are just what the -5? Less, which is to the left. Okay, so now when I write it in interval notation over here, On the left side, the solutions are going where? Negative infinity. And you always put parentheses for infinities. And on the right side, they're going to negative 5. And is it included? So parentheses. All right, number 5, they start out by giving you interval notation. So if you're not sure how to turn it into inequality, put it on the number line first and maybe it will help. So go ahead and label negative 6, 0, 6. At negative 6, is it going to be opened or closed circle? Closed. How do you know that? The bracket means it's included, so that means on a number line it's closed. And then the solutions go from negative 6 where? Positive infinity, so that would be right, correct. It's very similar except for the fact that in this one the negative 6 wasn't included, so it was parenthesis, and in this one it is, so you put a bracket. So yes, when you get ready to write this, it'll look almost identical to number 3 except for what? It'll have an equal to and then the negative 6. Alright, number 6, they gave us the number line. The solutions are what? Right, so less than or equal to, because isn't that closed on the 1? So 1's part of the solutions, so less than or equal to positive 1. So over here, how do I write that? Okay? Right. Okay, number 7 and 8. Go ahead and try 7 and 8, and then we'll move on to compound inequalities. Number 7, what does that say? Read it to me. Right, so we go to the positive 5. What kind of circle do we make on it? Open, and the solutions are what than that? Greater, which is to the right. So in interval notation, how do I write that? Right, 5 to infinity, and both are parentheses because the 5 wasn't included. Okay, number 8, they gave you the interval notation, so first maybe put it on the number line. Which one do we circle? Negative 3, opened or closed. And then the solutions go from negative 3 to infinity, so that's to the right. So doesn't that basically mean all the solutions are greater than negative 3? Right, and no need for an equal to bar because it wasn't included. That's why there was a parenthesis. We did do something similar. Okay, number 9. Now we're moving into compound inequalities. There's 2 different things going on. You have solutions over here, and you have solutions over here. So first I'm going to worry about doing this one, and then I'll do that one. So the solutions are, what number is this circle? Negative 5, and the solutions are what the negative 5? Less. Or you have solutions that are than 9. Is there a need for equal to bars? No, because both of them are open circles. Now to write this, okay, now for interval notation, you just do them separate. Okay, see how down here you had them written separately? Well, that's what we're about to do. Union. Okay, so from left to right, what's this section doing of solutions? Negative infinity to negative 5. Parenthesis and parenthesis. Then U for union. From left to right, what's this section doing? 9 to parenthesis and parenthesis. Okay, that's known as an OR inequality. The next one's known as an AND inequality because the solutions are shared. Okay, so the solutions start at negative 6, right? And the solutions end at positive 8. Oh, sorry. Yep, that's my goal. Alright, now, aren't all the solutions found between those numbers? So I'm going to put X in between the 2 numbers. Now, aren't all the solutions 7, 6, 5, 4, and so on, which is less than 8? And no need for an equal to bar because it was open? And aren't all the solutions also greater than -5 or equal to -5 because it was closed? Now, let's talk about why the signs go the same way, but I called one of them less than and one of them greater. Remember, it eats the bigger number. So isn't 8 the largest the solutions get? So see how it's eating the 8? But -5 is the smallest solution, so the -5 is not getting eaten. The x is. Everything in between is getting eaten. Does that make sense? Now for interval notation, it's pretty easy for AND inequalities. They go from -5 to 8. The -5 is a bracket because it was included. It had a closed circle. The 8 is not, so parentheses. One more. Okay, this time they're saying that the solutions are less than or equal to 2. So I'll put 2 over here, and it is closed circle. And the solutions are greater than or equal to -12. And it's also a closed circle. And since x is in the middle, that lets you know all the solutions are between -12 and 2. Because they're less than 2, which would be this way, 1, 0, -1, and so on. They're greater than -12, which would be this way, -11, -10, going towards the positives. Now for interval notation, you just write your two numbers, because left to right, that's all. It's not going to infinity. It's restricted on the left at -12 and on the right at 2. And they're both closed circles, meaning they're both included, so brackets. Now why don't you try 12, 13, and 14. Number 12, they give us the interval notation, and we see right away there's two different things going on. So maybe first put it on the number line. Put your -12 there. It's a bracket, which means it's a closed circle. And your 0, and it also has a bracket, so it's a closed circle. It says that the solutions go from -infinity to -12. And remember, in interval notation, that's left to right. So this is the furthest right it goes. Everything else is this way, -infinity. And then over here it goes from 0 to infinity, so from 0 to the right. Now we write those over here separately. The x is less than or equal to -12, or the solutions are greater than or equal to 0. Now this. But once you write it on the number line, can't you see that the solutions are less than -12 and greater than 0? And you just got to remember to put equal to bars because both of them were closed, because both of them were brackets.
Okay, see, this was easy.
Okay, number 13. Shh. This one is an OR inequality. We got two different things going on. We got -7 and we got +1. The -7, is it opened or closed? Closed, because there's an equal to bar. What about the 1? Closed. Now, it says the solutions are less than or equal to -7, so less than would be this way, right? And then it says, or solutions are greater than or equal to 1, so wouldn't that be this way? So now when we write it as interval notation, you just do two separate ones, because we have two different shaded sections. This shaded section from left to right goes from where to where? Right. -infinity is parenthesis, -7 is bracket. We also have from where to where in this one. And 1 is bracket because it's included, and infinity is parenthesis. Okay, number 14. Our numbers range from -14 to -4. And then all the solutions are in between those. So we put x in the middle because x represents all our solutions. Aren't those numbers less than -4? But aren't they also greater than -14? So less than -4, greater, see how it's not eating the 14? The solutions are greater than -14. Both of them are open, so neither one of them needs an equal to bar. And over here it would just be -14 to 4, both with parentheses. Okay, go ahead and try 15, 16, and 17. 15, 16, and 17. 15, 16, 17. Fernando, you done with those three? Okay, we'll do this. Yes. Number 15, we have an OR inequality because your solutions are less than -6 or you have solutions greater than 10. Okay, so over here you have to write two separate things. The solutions right here go from negative infinity to, and then parenthesis, and then they also go from, and both of them parenthesis. So number 16, the solutions are greater than 1 but less than or equal to 4. So on the 1 would be an open circle because it wasn't included. On the 4 would be closed. It was included. And then all the solutions are in between. Okay, so over here that would be written 1, 4, parentheses, bracket. Number 17, same kind of problem, but both of them are included, so both circles are closed. The solutions are in between because they're less than 5, greater than 1. So 1, 5, both with brackets. Okay, we're skipping number 18. Let's look at number 19. What kind of inequality is this? OR. Okay, so you got stuff going on with 2 and 6. Open or closed on 2. Open or closed on 6. Open. The solutions are what then 2? Which is to the left. And then over here the solutions are what then 6? Greater, so to the right. So over here you have to write two separate things. One to represent this shading, and from left to right it's going from, and then parenthesis, parenthesis. And then over here the shading is going from right. Okay, go ahead and turn to the back of this worksheet. Yep. Okay, turn to the back. First, I want to make sure you can read everything. So, make sure you can see that this is an open circle at -3, and this is a closed circle at 5. Over here, look, I'm just showing you where the open and closed circles are. Over here is an open circle at 5, or -5, I mean. Down here we have an open circle at -3 and a open circle at 0. Right here we have an open circle at -4 and at +4. Number 6, open circle at 2. Let's talk about 5. Do you see any circles on 5? No. So, and isn't everything bolded? So it means everything's been shaded? So what are your solutions? Everything, which would be left forever and right forever. Now, another way you'll sometimes see this written is they'll write all real numbers. Because doesn't that include every single number on the number line when it's bolded and shaded left forever and right forever? And then another way you'll see this is this symbol. This symbol, it's double back R, means all real numbers. Yes. Right. Okay, now let's go down to the bottom section. No, it's not. Now we're going to start looking at domain and range. Today we're just going to focus on domain. Now you already know some things about domain. Domain deals with which values, x or y? X. And the x-axis runs what direction? Left and right, correct? So when you're doing your domain, you always care about what it's doing from left to right. Now, what has been graphed on here is all of the solutions. So I'm going to shade all of the solutions. They go from here, and then over, and then up, and then back down. Now, you probably can't see it really well, but that was a little arrow up here and down here. So, let me say this again. When you're trying to figure out domain, domain is x values, which are left to right. So if I travel on this shaded area, which is all the solutions of this, and I go to the left side, how far can I go? Forever. And even though you probably look at that as, well, that's going up forever, as it's going up, isn't it slightly going left too? Can't you see that as the further it's going up, the further left it's getting from the y-axis? So it's going left forever, which is negative infinity. As I travel to the right side, as it's going down, isn't it also slowly going right forever? So this one is all real numbers. It goes left forever and right forever. Okay, so now let's look at the domain for number 2. Anytime the graph doesn't have arrows, but it looks like this with no points at the end, it's understood that those are arrows. Okay? The only time it's not understood to be arrows is when you see points plotted at the ends, endpoints. So for this one, this line is your solutions. Okay, I'll shade it. The line is all your solutions. So how far can you go left with solutions? Forever to the left, which is negative infinity, right? How far can you go to the right? Infinity. So that one has a domain of all real solutions. It goes left forever and right forever. We'll do that Tuesday. Okay, now let's talk about the domain of number 3. No. Okay, this time I'll shade the solutions. They go from here, and then down, and then over, and then back up. Now remember, domain is only concerned with the x-axis. And wasn't this a closed dot right there and right here? So when you're on this shaded area, which is all your solutions, how far left do you go? Negative 5. Who cares about that negative 6? It's a y value, and we're doing domain right now, so we only care about the x value. So it goes from negative 5, and it was a closed dot there, so bracket. And then how far right did the solutions go? Positive 5. The x value over there, and it's a closed dot, so bracket. Okay, number 4, what would the domain be? Negative 4 to 6. Because look, the x value of this point is negative 4. The x value of this point is positive 6. But they're both open circles, so parentheses on both. Okay, so what about the domain for number 5? What would it be? Negative 6 to 4, because this one has an x value of negative 6, this point has an x value of 4, and they're both closed, so both brackets. And then what about the domain for the last problem? Negative 5, because look, isn't there a point right here so it doesn't go forever? It stops at negative 5 on the x-axis. And over here the point stops at 7 on the x-axis, but they're both open, so parentheses. Your homework is 1 through 4. I did say that. I said this wasn't homework. 1 through 4. Okay, now listen, this is not on the pink sheet. I will take this up for a separate grade on Tuesday. So 1 through 4, you need to write it both ways. Write it with an equality sign and write it as interval notation like we did on the front.